Hello everyone. I'm going to introduce our next topic by jumping straight into an example. This video is introducing us to this idea of the sine rule, and in order to help us get there, let's say we have this triangle. I know that it is not right angled. None of these angles are 90 degrees. It's got this side of 8 meters. It's got an angle here of 50 degrees, an angle here of 35 degrees, and a side length that we're not sure about over here, a side length A. And we're meant to try and solve to find out what A is. Now, with the tools that we currently have, it would seem like this might not be possible, because we only know how to solve for unknowns in triangles when we have a right-angled triangle, so we can use our trig ratios. So in order to solve this question, we need to create some right angles in here that we don't currently have. So we're going to do that similar to how we did in the last case on area, the last video. And we're going to add in another line into this triangle, which is going to create some right angles in there. So let's say I draw a line straight down here. And that's going to create two right-angled triangles. So you can see now I've got one right-angled triangle there, another one there. I've split my triangle into two right-angled triangles. And this line here, let's give it a name. Let's call it H. I don't know what it is, and we'll see soon it actually doesn't matter what it is, but we're just going to give it a name, H. Now we have right-angled triangles, so we can use our trig ratios to work out some stuff. Let's first use what we have in this left-hand right-angled triangle to find out an expression for H. So here I've got an angle, I've got the hypotenuse of this triangle, and H is the opposite side. So I've got an opposite side and a hypotenuse, which means I'm going to use sine. So I get that sine of the angle, sine of 50 degrees, equals the opposite, which is H, over the hypotenuse, which is 8 meters. Sine 50 equals H over 8. I'm going to rearrange that by multiplying both sides of the equation by 8 to get that H equals 8 times sine 50. Now let's do the exact same thing with this right-hand right-angled triangle. Again, I've got an angle here. I've got the hypotenuse of the angle of the triangle, and H is again the opposite side. So again, I've got an opposite and hypotenuse, which means I'm going to use sine. So sine of the angle, which in this case is 35 degrees, sine 35 equals the opposite, which is H, over the hypotenuse, which we also don't know in this case. Let's just call it A. Now again, let's rearrange this equation to get an expression for H by multiplying both sides of the equation by A. So that's going to give me that H equals A times sine 35. Now, I have an expression here for H, and I have an expression here for H. So if H equals 8 times sine 50, and H equals A times sine 35, then it must be the case that 8 times sine 50 equals A times sine 35. I can rearrange that to solve for A by dividing both sides of the equation by sine 35. So I get 8 times sine 50 divided by sine 35 equals A. And I can work that out on my calculator. 8 times sine 50 divided by sine 35 equals 10.7 meters. So there we go. I've solved for A by creating some right-angled triangles that weren't previously there. In the next video, we're going to generalize what we've done here to create a general formula that we can use for any similar problem with any triangle.